Hello, I am Lieutenant Colonel Diana Laux, an Academy Professor with the Department of Physics and Nuclear Engineering at West Point. In this presentation, I will be talking to you about developing leaders of character through space weather education and applications. My contact information is listed on the slide, as well as the URL to our department's website. Although my office phone number is listed, we are primarily teleworking during this challenging time, and email is the best way to contact me. Here is the purpose and agenda for the presentation. This is an opportunity for me to introduce you to West Point and to the House of Paine, as the Department of Physics and Nuclear Engineering is known, and to inform you of a handful of ways that we are educating both current and future Army leaders of the sources and impacts of space weather, and making space weather research accessible to them. The United States Military Academy at West Point was founded in 1802 in the Hudson River Valley, just 45 minutes from New York City, on land originally used as a Revolutionary War fortress. Continental soldiers built forts, batteries, and redoubts, and extended a 150-ton iron chain across the Hudson River to control river traffic during the war. Every year, roughly 1,000 graduates earn a Bachelor of Science degree in majors supported by 13 academic departments, to include the House of Paine. Faculty at West Point are 3/4 military and 1/4 civilian. Junior faculty are primarily Army officers midway through their careers who hold master's degrees. Senior faculty hold PhDs and are either Army officers at the culmination of their military careers or are civilians hired under Title X U.S. Code. It is my honor to now welcome you to the West Point House of Paine. Our department is chaired by Colonel John Hartke, Professor of Photonics. Before you are a few snapshots of what life is like in the House of Paine, from exuberantly supporting our NCAA and intercollegiate student athletes to allowing Master Yoda to display some of the many physics principles in the universe. We are happy to have long-standing relationship with both the directed energy and space communities, as evidenced by the cadet performing a laser experiment in the lower left, and Colonel retired Tim Kramer, a former faculty member, now astronaut, who is proudly flying a department guidon aboard the International Space Station. The House of Paine is a family of military and civilian faculty whose mission is to educate and inspire cadets to be leaders of character, prepared for a career of service to the nation as an officer in the United States Army. We do this through physics, nuclear engineering, and space science coursework and research, and our primary line of effort is to create a diverse and inclusive family environment that promotes respect, trust, and leader development. In March, we hosted one of the last in-person national conferences for the Directed Energy Professional Society, or DEPS, and we have been designated by the American Physical Society as one of 13 host sites across the United States and Canada for the annual Conference for Undergraduate Women in Physics in January of 2022. There are 4 programs within our department that sponsor coursework. The Core Physics program teaches first and second semester calculus-based physics with lab. The Advanced Physics program instructs our physics majors in undergraduate physics with an emphasis on photonics. The Nuclear Engineering program hosts our ABET accredited and nation-leading nuclear engineering major. And our Space and Missile Defense program hosts the Space Science major, for which the first graduating class was this past academic year, 2020. Finally, our research program spans the department instruction to allow both cadets and faculty to apply their knowledge to solve Army, DoD, and scientific problems. Some of this research is sponsored by 3 research centers that are associated with the House of Paine. The Photonics Research Center is a collaborative effort across Paine and the Departments of Electrical Engineering and Computer Science and Chemistry and Life Sciences to study all things photonics, including directed energy. The other 2 centers are sponsored by external agencies and provide a path for each agency to sponsor research and internships for cadets and faculty. The Nuclear Science and Engineering Research Center, or NSERC, is sponsored by the Defense Threat Reduction Agency and was founded in 2007. And the Space and Missile Defense Command Research and Analysis Center is sponsored by its namesake and was founded in 2009. By now you may be asking yourself, why space at West Point? It turns out that the Army has always been involved in space, so much so that in 1841, W.H.C. Bartlett, our building's namesake, used the first West Point Observatory to make an observation record of the comet of 1843 and later a total solar eclipse. You can see an engineering diagram of the telescope he used. At the dawn of the space age, the first U.S. satellite to ever enter orbit was Explorer 1, which was launched in January 1958 and was developed at Redstone Arsenal by the U.S. Army Ballistic Missile Agency. Over 20 West Point graduates have been or are U.S. astronauts. Spanning the space age, these include Buzz Aldrin, Frank Borman, Ed White, and Anne McClain. And we are quite proud of our latest update to the West Point Observatory. The commissioning of the current Bartlett Hall Observatory with a fully automated 16-inch Schmidt-Cassegrain telescope with filter wheel and digital imagery suite in 2015 as part of the Bartlett Science Center renovations. There is also an operational need to have space at West Point. The Army is the single largest user of space-enabled systems in the Department of Defense. Space Command and the U.S. Space Force were established in 2019, helping to codify space as a domain of battle alongside land, sea, air, and cyber. And advances in space-based technology with space weather vulnerabilities like GPS increase not just our military's, but our society's reliance on space-based applications. All of these combined with academic advances in space weather data collection and analysis capabilities, such as the installation of the Advanced Modular Incoherent Scatter Radars at Poker Flat and Resolute Bay, the North and Canada faces of RISER are shown here, make it increasingly important for the Army to take part in space weather research, especially as it both increases our intellectual capital and allows us to bridge the gap between research and operations. I want to take a moment to highlight the curriculum at West Point that a space science major will take. Shown here is what we call the 8-term academic program, or 8-TAP. A cadet at West Point is restricted to 4 academic years of instruction before graduating and commissioning as a second lieutenant in the United States Army. A broad liberal arts curriculum is at the core of a cadet's instruction to include such topics as English, history, language, geography, psychology, economics, political science, and law. The bulk of these courses are taken during the freshman and sophomore year. A space science major will additionally take coursework in advanced mathematics, choose between modern physics and mechanics, take foundational courses in electrodynamics and electrical engineering, complete a 2-course optics and laser sequence and 1 in remote sensing, and complete 4 space science courses. These are astronautics, how we move in space, how we get to space, and what we put in space. A course modeled after the Air Force Academy's core course, but taught at a slightly higher level as only majors and minors take the course at West Point. Space physics is the study of our solar system, but primarily focuses on the aerospace environment and its effect on our systems. Observational astronomy pertains far less to what we observe in space and far more on how we observe what is in space, with a focus on the use of optics and mirrors in binoculars and various telescopes with CCD arrays and multispectral imagery capabilities. Finally, astrophysics is about everything beyond in our universe. This coursework prepares cadets to go into any facet of space science that they choose in industry and academia. But there are many opportunities for cadets outside of the classroom, like research. As we all know, the conduct of research allows both cadets and faculty to apply their skills outside of the classroom. At West Point, we primarily focus on Army and DoD problems, but basic science understanding is also addressed. We have seen a tremendous growth in the emphasis on research amongst cadets and faculty since 2000. In academic year 2020, we had 58 cadets both in and out of our department sign up for research relating to physics, nuclear engineering, and space science. The global pandemic did not hit us as hard as we thought it might, mostly because cadets were primarily engaged in data analysis by the time we transitioned to remote teaching, which allowed us to maintain 3/4 of our research enrollment. The cadet researchers span most of the West Point academic departments to include freshmen, known as plebes, sophomores, known as yearlings, juniors, known as cows, and seniors, known as firsties. Faculty advisors also span many departments and include both junior and senior faculty. Next, I will highlight 3 projects that either provide opportunities to conduct or are inherently space weather research. Sponsored by the House of Pain through a collaboration between the Cadet Astronomy and Amateur Radio Clubs, balloon satellites provide a fun way for any cadet to learn more about space regardless of their major. It also serves as a platform for various scientific and operational payloads. Scientific payloads include upper atmospheric characterization and radiation detection and measurements of time dilation, while operational payloads include station keeping, horizon and ground imagery and video, Wi-Fi detection, and communications. It's fun to watch the trajectory of a balloon satellite as it lifts to peak altitudes in excess of 100,000 feet before bursting and zooms back to the Earth, where avid amateur radio operators in the Hudson River Valley join cadets in the race to whatever landing site it is guided towards. It's even more fun to watch the chase while sitting in Kandahar, thanks to that wonderful thing we call the internet. Balloon satellites also offer a great mechanism to test payloads and subcomponents of West Point's CubeSat, the Black Knight satellite. The Black Knight satellite project was established in 2007 by an Army Space Operations officer who was serving as a junior faculty member in the Department of Electrical Engineering and Computer Science, or EECS. It has been partly funded through the SMDC Research and Analysis Center since its establishment in 2009. I had the privilege of watching Black Knight 1 launch in September 2013 while I was serving as the Space and Special Programs Chief in Kandahar, Afghanistan. And although the satellite's beacon was never located, it was a step in the right direction for keeping West Point cadets engaged in space and highlighting the Army's involvement in and need for space capabilities. Cadets will be working on Black Knight 4 starting this fall, a joint venture between the House of Pain and EECS and partly funded by SMDC. And our goal is to design a low-cost, on-demand, deployable cube satellite that uses radiation survivable commercial off-the-shelf technology to perform operational missions at LEO near 1,000 kilometers in altitude. An opportunity to expand the Black Knight satellite program beyond West Point and to join the efforts of our country's military academies exists via a working group with members of West Point, the United States Naval Academy, Air Force Academy, and Coast Guard Academy. But West Point faculty and cadets desire to know so much more about the space environment than just being able to deploy missions into it. Since arriving at West Point following my doctoral studies, I have been successful at recruiting and integrating cadets into my research, although the greatest challenge that I have faced has been scoping the work to the undergraduate level. I have done this on two major fronts: high-latitude GPS scintillation studies and auroral spectroscopy. Cadets engaged in GPS scintillation studies have been to this point focused on several aspects of the overall project, including streamlining experiment projections for both the Poker Flat and Resolute Bay incoherent scatter radars and visualization of experiment results. Please see Cadet Adam Hoxing and Cadet Charles Debchak's presentations under the Data Science and Data Assimilation section. Cadets have also been working towards streamlining the processing of 100 Hz data to calculate the phase and amplitude scintillation indices, sigma, phi, and S4, or cadets have been attempting to determine the level and spread of scintillation required before significant degradation to the position and timing solutions are detected at the receiver in an attempt to bridge the gap between research and operations. The latter two are developing and should get to presentation level during the next academic year. In the field of auroral spectroscopy, the YouTube link to now Second Lieutenant Anna Maria Deer's Projects Day presentation is on the slide. Updated since then, her work correlating solar wind measurements to the appearance of diffuse aurora, which is co-sponsored by Dr. Don Hampton at the University of Alaska Fairbanks, has been submitted to JGR Space Physics for publication. I sincerely hope that you have enjoyed this presentation as much as I have in working with the cadets and faculty who have made this possible. The Army has always had a hand in space, has sent numerous satellites to space, is the #1 ground user of space, and is one of the top stakeholders for space in the future. I hope that during this presentation you have learned that West Point is leveraging internal and external capabilities, engaging with industry and academic partners, and advancing operational knowledge and impacts of scientific discoveries, especially as they apply to the sources and impacts of space weather in the Army and DoD operations. Thank you for your time. Please feel free to contact me with any questions. The best mode of contact is email.